topic from the nuclear physics, that is the concept of nuclear stability. Now, in this concept, we will understand what is the thing that makes a nucleus stable and what is the cause of this nuclear instability, and due to this instability what's the main reason which causes the radioactivity. Now dear students, we know in case of an atom, uh, we do have a nucleus that is embedded inside the core of this central core of this atom, and this atomic nucleus consists of nucleons as well. So in nucleons we have protons and neutrons. These nucleons or protons or neutrons are embedded inside this nucleus under the action of a very strong short range force. That's what we call as the nuclear force. Now it's a nuclear force which makes the nucleus stable, or which binds together the nucleons. Now even though there are the protons have the positive charge, there will be electrostatic force of repulsion, but we know this nuclear force is 100 times more stronger than electrostatic force of repulsion. Electrostatic force of repulsion. So this means if there is the repulsive force inside the nucleus between two protons and there is an attractive force, the nuclear force, the resultant force will be attractive, and that is what makes the nucleus stable. Now we just have to understand what are the various factors. So this is the one of the factor which makes the nucleus stable. Now if you will see, around of we do have many elements, and around apart from these elements we have radioactive substances. We have 114, and we have certain radioactive substances, and all these elements do have isotopes. So there are around of 2500 such nuclides, and apart from that, out of these 2500, only 280 are only stable. Only 280 nuclides are stable. Now we just have to understand what is the thing that makes these rest 2500 minus 280 unstable. So there are many factors which makes the nucleus unstable. So now we will understand the reasons for nuclear instability. So nuclear stability is determined by many factors. So one of the factor is the concept of binding energy per nucleon. So we have already discussed this in the sessions, that why we are concerned with binding energy per nucleon, not the binding energy only. We know binding energy is the minimum energy or minimum work done that you have to do so that you can separate the nucleons apart, at infinite distance, wherein there will be no resultant attractive force between those nucleons. Now how this binding energy per nucleon determines the nuclear stability? Do remember, more the binding energy per nucleon value, more is the stability of the nucleus. That's the reason if we will check for the iron, the binding energy is 8.8 mega electron volt binding energy per nucleon for the iron. That's why it makes iron has the most stable nucleus. You might have gone through this graph as well as we did in the sessions when we discussed the binding energy per nucleon graph. with respect to the atomic number, and we just saw something like this is peaks, then we study like this way. These undergo up to this they undergo nuclear fission, these undergo fusion. Here is the stability criteria that we have already discussed in the sessions as well. So the first criteria for the nuclear stability is the binding energy per nucleon. Now, more the binding energy per nucleon, more will be the stability of the nucleus. That is what we have to understand. Now, the second factor, which is what we call as nucleon ratio. Nucleon ratio. What does this mean? Dear students, if we will check a nucleus, suppose if we have the nucleus, and inside this nucleus we have protons as well as the neutrons. Now, if we will check neutron to proton ratio, it is the thing which determines, let me denote it by N, let me denote it by P. It is the thing which determines the stability of the nucleus. Now, if I'll take three atoms X, Y, Z. Okay, so suppose if number of protons and number of neutrons and number of protons is equal. This is the first thing that wherein we will discuss the equal ratio when the number of neutrons and number of protons is equal. Now, this is possible only when the let's discuss about first example in case of the lighter nuclei. So if we will talk about the atoms which have lesser number of the nucleons, those we simply categorize as the lighter nuclei. Do remember that lighter nuclei are only stable if they contain protons equal to neutrons. When the number of protons and number of neutrons is equal, the nuclei will be stable in case only it is the lighter nuclei. That means the number should be very small. Now, if we'll talk about the case of the heavy nuclei, do remember the heavy nuclei will be stable only in case when it has more neutrons than protons. Why is it so? Suppose if I will reverse the condition, if I will make more protons than neutrons, then it will become unstable. Why so? Let me explain that. First thing, we just have to understand heavy nuclei will be stable in case when it is neutron rich. Now, if you will make the same atom or same nucleus the proton rich substance, what will happen? If the protons exceed, what will happen? There will be a greater number of, or we can say the greater magnitude of repulsive force between them. So if there is more repulsive force, that can cause the distortion of the nucleus. So we can say more neutrons in that case you need to provide so that there will be sufficient attractive force. So if the protons are more, that means there will be more repulsive force, right? So that means you just have to give more number of neutrons so that they will provide the strong attractive force. That means it will be in need of, this atom or nucleus will be in need of more neutrons just to make the nucleus stable, right? So that's why we just discuss this proton neutron ratio in case when the neutron number is greater than the proton number. That is the second criteria, nucleon ratio, or we can say neutron to proton ratio. Now let's come and discuss the third important aspect of the nuclear stability. It is actually this is a consideration that when we determine whether it contains, like if we will have to check the nucleus and its stability, we can just discuss the nuclear stability under a certain consideration. And what is that consideration? That consideration is very simple. That is whether it contains whether it contains even or odd number of protons and neutrons. So even an odd concept of proton and neutron number determines whether the nucleus is stable or not. Now understand how it affects. So see dear students, if we will analyze it, suppose if I'll take uh, the number of stable nuclei. Now if we will check the number of stable nuclei that we have is, let's say, 165. If the number of protons, if number of protons is even and number of neutrons is also even, in that case when we just checked it, when the number of protons was even, number of neutrons was even, out of the periodic table we just saw there are 165 stable nuclei. Now if I will just make the proton number even and neutron number odd, what was done by the consideration and what was found, only 57 nuclei were found to be stable. And suppose if we will just reverse it, if number of protons are odd, the number is odd, and the number of neutrons is even, the stable nuclei that was found was only 53. Now if both are odd, we'll see the number of neutrons or number of protons, if they are odd, we can say the stable nuclei that was found is only 6. So from here, if we just want a nucleus to be stable, or if we just have to check whether the nucleus is stable or not, there should be a sufficient criteria or the justifying criteria on the basis of number of neutrons and the protons, that number of neutrons should be even and number of protons should also be even. So we can say the stability of nuclide is connected to somewhat to relative number of neutrons and protons. For small nuclei to be stable, we know that protons must be equal to the neutrons for lighter nuclei. However, if we talk about the larger nuclei, there should be more neutrons. Now, when such criteria are not met, let me talk about this. If there are odd protons and neutrons, this will lead to unstable nucleus. And due to this instability of the nucleus, this will ultimately make that nucleus as radioactive. So radioactivity is actually the cause of the nuclear instability. Now in the upcoming sessions we will be discussing about radioactivities in detail.